let's have a look at one research project, just one among very many, of fairly recent genesis. So this is a project that started about in the early noughties, 2003, I think. And it's called the Human Speechome Project. The name is a play on the ambitions of the Human Genome Project, but this project is slightly different. It was performed by a guy called Deb Roy from MIT Media Lab, and in this project he was doing something which some of you may find strange, but he was following in a tradition of scientists who study their own children. This was true of Charles Darwin, it was true of Sigmund Freud, it was true of Jean Piaget, and it's true of Deb Roy. That doesn't always go well. If you paid attention to the material on John Watson, the behaviorist, you'll find that his application of his theories to his children was not very good. But I think this is a much happier case. It's an extraordinarily ambitious project. It ran from 2005 to 2008, there's my dates. And it set itself the goal of capturing the entire linguistic output and linguistic environment of one child, over 3 years. That's amazing, isn't it? How would you do that? Well, we're talking about early years, we're talking about the very first steps in acquiring language. So the child is going to be in the house an awful lot. And what Deb did was, and his wife, was they modified their house. And they put in overhead video cameras in every room, and microphones in every room. And they changed their basement into a huge big data server. And they recorded amounts of data which at the time were staggering, and even now, almost 20 years later, are still kind of awe-inspiring. There were kill switches in every room, but basically, as long as nobody intervened, everything that went on in a room in which people were in was recorded. So you can see here, for example, the view from one camera looking down here in the kitchen. Yeah. No one had ever thought of doing this. No, the ability to do this didn't exist prior to this time. And one of the first and perhaps the biggest challenge this faced was, what the hell do you do with so much data? There was vastly too much data for anyone to go through and manually annotate everything. So a lot of the very hard work that went into this project was concerned with developing methods for automatically extracting things from this enormous data set. And just to give you a flavor for the kind of things that come out of it, one of the first products involved going in and finding every time the child said the word water. Now, in common with many children, when this child produces a word for the first time, it bears little resemblance to the adult form. Children often have their own idiosyncratic words for things, and so this child first produced the word water as gaga, and it's only because we're dealing with caretakers and parents who are living with the child, know the child very well, that we could be confident in this. But one thing they did was dig into this database and take out every utterance of the word from its first appearance until it achieves the final form, more or less, of water. And now you can play them back to back. You can listen to them. And while you're doing so, it's a bit like listening to a flower open. I'll just play it for you here. You got there. It took a while, didn't it? Took a long time. Nobody'd ever listened to language like this before, and you can practically see the child producing something, and that something being shaped until it reaches its final form. And that's just the audio. Of course, there's video film to go as well. And now the question comes, what kind of questions can you ask of data like this? Here's an example of the richness of the data again, where we just sample the word ball, but look at the visual nature of the situation in which the word ball is produced. I'll stop that there. So you can see the richness of this data. What kind of questions can you ask that you couldn't have asked before this? One remarkable thing that Deb did was he showed that words have their own geographies, that some words are much more likely to occur in the bedroom than in the kitchen, for example. There are certain words which occur primarily at the hall door when you greet people. And a database of this kind can be used to map out the linguistic geography of a house. You can look at the association of words with certain times of day. So there are words concerned with going to bed and getting up, for example. One preliminary result, it's not a very strong result, but it's a very interesting one, is the following. We saw that this child started producing gaga as water. Let's call that the birth of the word water. And it happened on a particular day. And some other day, another word will be born. There'll be a day that the child says truck for the first time, and there'll be a day that the child says ball for the first time. Call those days the birthday of the particular word. And now for any given word, look at the sentences in the weeks and months before it appears, and look at the sentences that contain that word in the month after it appears. And you can do this for each word separately, and because each word is born on a different day, this is distributed over time. There's no way anyone could be conscious of what's going on, but we can align all this by the birthday of the word, and that's the data you see there. At the bottom of the graph at 0 is the moment at which a given word appears. Prior to that, you can see the complexity, measured just in length, of sentences containing that word before the word appears and after it appears. And what we see is a startling relation that sentences containing a word that has yet to be born get simpler until the child produces the word, and then get somewhat more complex after that. It's a fairly weak relationship, but it shows that there is a delicate, intricate dance between the speech of the caretakers, which is the environment of the child, and the child's own capacities in production, which we are not aware of, we could not be aware of, but you can bring out through this kind of profound data analysis. This should remind you of what we met in the video on Lev Vygotsky. Vygotsky's zone of proximal development emphasizes the fact that when we first acquire capacity, we do so in an environment that supports that. And we later internalize it and become masters of that. There's an important theoretical point to be made here. The Human Speechome project allowed us for the first time the direct observation of the linguistic environment of the child. Now, claims have been made about the linguistic environment of the child before, claims with profound impact. In particular, Chomsky had motivated his entire view of humanity, of mind, and of language with reference to the creativity of language, of course, but also the poverty of the stimulus. That is, he said the linguistic environment of a child is just terribly poor, and so biology must have done all the work. Chomsky takes out a loan on biology here. That was a pronouncement from the armchair. He hadn't checked. The Human Speechome project gave us the first possibility of looking at the linguistic environment of a child in anything other than informal fashion, and boy howdy, it turns out to be interesting, and the situation is nowhere near as simple as was previously thought. So that's a nice example of some complex, fairly recent work in infant development that opens up all kinds of doors.